ouvir nada. Nem sequer barulho de fundo. Certo?
Não estou escutando nada também. Não,
Nada.
nada. Vou colocar tudo isso no listado, porque... Pode manter o stream, vou colocar como no listado pelo YouTube direto.
Pá. Ainda estás ligado com o vídeo, não estás?
Sim, eu estou com o vídeo, coloco como no listado.
Pá.
Estou cansado desse problema aqui.
Estou a ouvir.
Eu também escutei, sim, tá baixo.
Mas muito baixo.
1, 2, 3, 4, 5. Sim, aparece aqui, só que tá muito baixo.
Eu tenho 2 microfones.
Tá pegando desse aqui, talvez?
Não, está desligado.
Esse tá ligado.
Porque não está com volume. Tipo aqui, tu falas e ele...
Tudo bem, tudo bem.
Posso aumentar aqui, se calhar.
Tô chamando aqui um amigo meu que ele entende OBS, mas não sei se você vai entender agora porque eu não avisei nada pra ele.
Olá.
A conta está aqui, tá baixo,
Sim.
mas consegue.
Agora estou a ver como é que... Se eu tiver com isto assim aqui... Isto é muito baixo. Isto. É... Ok. Deixa eu ver se posso. Isto. E... Desculpa. Sou eu de facto. Aqui ele não está ao máximo.
Hello.
Hey.
Eduardo's friend.
Yeah, exactly.
You know OBS?
No.
OBS? Okay.
No, not really.
Okay, because I tried to set up the environment, the audio, but a lot of issues.
Oh, sorry.
Nothing works.
No worries.
Nothing works.
The usual, right?
Okay. How are you? What's your name?
Ask me about the Kahoot.
Oh, yes.
And
Of course.
for
I
the
do
result.
not document.
Tá. O que é que eu estou a fazer de mal? Precisa de power? Precisa, se calhar. Vou experimentar isto.
Vou ver eles agora sobre isso.
Olá. 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 Olá, bom dia. Tenho o microfone ligado diretamente ao computador. Tirei a câmera, porque a câmera estava a dar problemas. Tenho o receptor com aquele bocadinho vermelho ligado no botão, no buraquinho vermelho do computador. E o som no OBS parece-me estar ok, mas eu falo com o microfone e ouço muito baixinho. Aquilo precisa estar ligado ao USB. É assim, eu estou a falar neste momento, estou com o microfone perto da boca, e a linha vai ao amarelo no display do receptor. Ele depois faz a redução dos decibéis aí. Ok. Com a redução, não é? Então, pá, mas isso é o cabo, é o teu. É aquele vermelhinho. Isto, se eu tirar o cabo e puser só o USB, ele transfere o som para o USB? Ou é só para carregar? Ok, então vou experimentar por USB. Sim. Sim, ok. Obrigado. Vou tentar. Alright. Até já. Consegue? Está a sair som ainda? Estás com o vídeo aberto?
Alguma coisa? Fala alguma coisa?
Olá.
Tá bem melhor o áudio agora.
Está melhor?
Tá melhor. Tá indo pro YouTube direto. Você não vai ter retorno aqui, pelo... Ah, tudo bem.
Entendeu?
Nossa, tá com um delay enorme.
Tá.
Tá, ok.
Olá. Olá. Gente, deliciosos.
Tá bom.
Espera aí. Ok.
Agora
Tá bom?
tá bom.
Falando de volta.
Ah, quando o pessoal chegar depois da primeira palestra, na abertura, aí traz. O pessoal só vai encontrar mais fácil o evento. Mas daqui a pouco trazemos. Tá, eu vou começar aqui.
O que é que falta?
Iniciar Cadê o Caio? Ah, tá aí. Pronto. Vamos começar daqui a pouco, ok? Eu vou só começar aqui com o microfone. Depois você pode ficar aqui no palco para fazer a troca rápido. Aí você vai puxar o Dave, depois o Tijo chegou? Não. Não? Oh meu Deus, cadê o Tijo?
Eu tô escutando aqui, só que tá baixo.
Tá tudo bem, sem problema.
Mas tá baixo o som.
É porque na verdade tá com a câmera errada ali, é pra ser o idle. Já alguns comentários aqui. Mas é como... Tá, fica assim. Hello everyone. Okay, I'm sorry for the delay. You had some issues on OBS as the last year. Okay. And okay, so hello. Let's start the first GambiConf European edition. Okay, it's a pleasure to have everyone here on the Saturday in the middle of the summer in Portugal. Okay, but everyone probably is wondering about what is GambiConf, what you can expect about it, because it's a kind of new event, a different event. For example, you have events like CodeBeam. That's an event focused on language that runs on the Beam virtual machine. But it's not the case for GambiConf, because GambiConf isn't about a language or environment. We also have events like GoTo Conference. That's an amazing event focused on technologies, new researches, forefront new things, etc. But major part of the GambiConf talks isn't about the last new research on the edge of the technologies. And it's not talks necessarily about the things to be used for your workday. Yeah, of course, you have talks about things to use in your workday, but it's a side effect because the GambiConf goal is simple and simple. We just want to make computer fun. Because we are developers, we like to code, to create new projects, patch projects, and we also want to share the projects that you are developing in your free time. And you can learn a lot by doing patch projects, because you can test new ideas that's hard to apply in your job. And so, in short, you can also understand better GambiConf by checking how it came about. BangBangCon is the event, is the major GambiConf inspiration. And in this event, it's about a 10 minutes talk about a crazy talk about surprise with computers, etc. And in this event, I found this event by this talk about to play game run inside of PDF file. And yes, it's possible to play game inside of PDF file like this one. And from this very fun talk, it's nice because you can explore how PDF format works. You can think, okay, you can run game inside of PDF. Maybe you can try to run game inside of other file formats. You can try to play DOM inside of PDF. It's a nice idea to test new things, to explore new subjects. There is also a very good talk about explain tail call optimization by a musical. So it's a technical topic by a fun way to explain. I was thinking more about other events like BangBangCon, and I found Sigbovic. That's an event focused about making errors with computer. And it's one of the talk about explain how PowerPoint is Turing completeness. And it's a fun talk because by this crazy talk, you can learn more about how study completeness. You can be more motivated to learn computer science topics, etc. Both GambiConf and SICBOVIC are very nice events, but there is an issue. They are too far, because both of those events are American events, but we are in Portugal. There is an ocean divide us. And I'm in Brasilia, okay? And I know that there are many amazing people in Brazil that make fun projects in the same bang way. But there is a missing place to share this kind of talks, because there's no event about pet projects or fun ideas that's not useful. There's a more of crazy talks about surprising things. So what's the solution? Let's start a new event called GambiConf. And you had the first edition last year, and you have 2 days about many talks about using segfault as optimization, making computer just use water. We had talk about the game emulations, talk about running down inside of oscilloscope, and it was very nice moment to share different things. And now that I'm living in Portugal, I know that the same issue that you had in Brazil also happens here, because was missing a place to share this kind of talks. So we decided to start a new event based on GambiConf, but in Portugal, the European edition. So in short, GambiConf is a tech-agnostic conference. You have talked about many talks about OCaml, you have talked about the tests, you have on this online they have talks about all the things, or the language, or the environments, because you are not focused on the technology itself, but what's unique on your topic. Also, we want to motivate people to try new ideas for the simple sake of curiosity. Test new ideas for fun. It's amazing. And so the schedule for the in-person day. Just a disclaimer, okay, you had 2 speakers that were supposed to be here, but they had some travel issues, okay? But you have, despite that, I have a amazing talk started by David that to teach us about how tests can be fun using mutation tests. You have talk about the video transcoder. It's a completely new topic for many people. After that, you have 45 minutes coffee break to share new ideas, talk, etc. After that, you have a talk about the game compiler using a very different language called Fort. And the last talk is how over-engineer CSS. And at the end, feel free to share your topics, your GitHub, your projects on the Lightning talk. And at the end of the day, you have a Kahoot that with the question about the talks that you saw before. And to make it happen, I have a lot of partners. The first one is 42 Lisbon, that's the owner of this venue. Also, I want to thank 8ref that is sponsoring one of the speakers. We also have Reactor that sponsored the coffee break and one of the speakers. Kumbuka is sponsoring one of the speakers. This podcast that's helping to spread the word. And if you want to push GambiConf and this idea about make computer fun, you can become a GambiConf partner. And please follow us on the social media. I am more active on Twitter, okay? And you also have a LinkedIn page. And I'm Bruno Macabeus, the guy who's organized this event. I work at Anima. You can follow me on my GitHub, my Twitter, bmacabeus. I will be busy on the backstage and spend a major part of the day with Caio Gomes, is your master of ceremony. Thank you.
Hello guys, it's a great pleasure to be here in front of this amazing audience. It's nice to be here again in 42 Lisbon. Of course you don't know yet, but I was a student of 42, and this environment that 42 gave us is really nice. It's really welcoming. Unfortunately, we are not in a workday, because in workdays this place gets packed with people. But now we have a really great experience to share our ideas, our crazy ideas at GambiConf. Well, the first question that I want to make is to you guys. What's your name? Antonio. How old are you? 20. Okay. There's a very interesting thing about our first speaker, because our first speaker has more experience than you have of years lived. Basically, he has a great experience. He has over 37 years of experience. So, well, when you were a baby, he was already working on this field. So, please give a round of applause to Dave, our first speaker.
Here's the audio.
Okay.
And I'll work on the video. If I can type my password correctly. Here we go. Get that set up there. It's not showing up on the main screen.
Send the link on Twitter, please. You need to open the link on Twitter and start to share the screen there. Okay.
A link on Twitter, okay.
Yes, because we are needed to update the environment things. It's nobody's sharing the screen now.
That means I gotta turn on the Wi-Fi.
Internet. Yes, no worries. And the first one.
Yeah, there we go.
Grash with at
42. Yep.
Okay. I forgot to do it before. Okay.
And then it's probably going to take a moment to connect to my VPN.
Okay, no worries.
Yeah. Oh, maybe it's not configured to auto-connect. So, a link on Twitter.
Okay, send the mentions. Okay, this link. This link.
Video Ninja.
Okay, send Gambiarra. No, can I type?
Tell you what.
Okay, share with share screen, please, and select screen share. This one, and set this one, please. I think you need to allow Chrome to. Oh my God. Okay. You can click. You need to enable, please. This one. Now you need to reopen. Catch now. You need to reopen. Okay, no worries. It's quick. You can close this window if you prefer.
Yeah, let's just make sure it works.
Okay, I think you need to open it manually.
All right. Oops.
This one, yes. Okay, now you'll be able to share this screen. Can I type? Share with your own. Share a screen, this screen, share a screen. No worries.
Yeah,
don't
that's
need
fine.
the audio.
I don't have audio in this.
Yes, now you can go to the screen and play here. Now it will show there.
Well, maybe we can just turn that around. Oh, saw something
Yes, I
flash
saw
on there.
about the cursor. I can see your cursor there. It's your computer?
Yes.
Ok. Você pode duplicar a tela ao invés de... Ok. Apareceu lá. Volta como estava. Ok. Tela cheia.
And that'll automatically follow along with mine through Ninja or whatever.
Yes, no, it's because we had some issues to use this device. Okay, so you need to use this crazy environment to make it work. Kind of work.
Ooh, psychedelic.
Parece que vai. Quem tem epilepsia vai ter problema. Tem como fazer com que não duplicar, mas somente duplicar a tela? Mirror, isso, perfeito. Agora vai ser mais fácil.
Eu não gosto de ter isto mesmo.
Não, é só por enquanto. Perfeito. Just test the next slide. Okay, it's fine.
Okay, except now that starts the timer going, so.
Não, sumiu. No. Okay, it's fine. Oh, sorry? You want
Yeah,
to
I think-
share?
I think-
Tá dois ali, ó. Olha ali de novo. Tá repetindo ali.
Okay.
See what arrangement.
Yes.
There we go.
Play.
Yeah. Thing is, once you go to the next screen, that starts the timer, so I don't know
Okay,
how
okay.
much time I've got left.
Okay, no worries. Okay.
All right, I guess we can just ignore that we've got a little extra repeat over there. Though if you could arrange for the whole thing to shift over so the repeat's over here where I'm standing, that would be okay. All right, where'd my water bottle go? Ah. Vou precisar isso.
Just give me a second, please.
Okay. Now,
Have this mirror.
since one of the speakers backed out, at least that gives us time to do this. Meanwhile, if you caught that URL on the slide, you can download the slides so you can follow along. Because I'm probably going to be blocking some of it. Oh, if they shrink it and move it over, maybe that'll solve that. There we go.
Almost there.
It's all good. Can start, please.
Ok. Olá, Lisboa. O meu nome é Dave Aronson, sou o T-Rex de Codosaurus e vou aqui no meu pterodátilo de estimação para vos ensinar a matar mutantes. Mas vou fazê-lo em inglês. So what on Infinite Earths is the big difference between mutation testing and all the other software testing techniques? The big difference is that mutation testing, that most of the others are about checking whether our software is correct. But mutation testing is checking for two other qualities and assumes that our software is correct. In my opinion, the more important of these two other qualities is that our test suite is strict. And to check this, a mutation testing tool will try to find the gaps that let our code get away with unintended behavior. Once we find these gaps, we can fill them in by either adding more tests or by expanding and improving any existing tests that might be suitable. Lack of this strictness usually comes from lack of tests or poorly written tests or occasionally poorly maintained tests that didn't keep pace with changes in the code. The other thing it checks for is that our code is what I call meaningful, by which I mean that any tiny little semantic change, as opposed to strictly syntactic or structural, will have a noticeable effect on the behavior of the code. Lack of meaning, or lack of meaningfulness if you're not into the whole brevity thing, generally comes from code being unreachable or redundant or otherwise just not having any real effect. When we find meaningless code, we can figure out why it's meaningless and either make it meaningful if that suits our purposes, but the usual fix is to just remove it. Mutation testing puts these two together by checking that every tiny little change that the tool knows how to make will indeed have a noticeable effect on the behavior of the code, and that our test suite is strict enough to notice that change and fail. Now, not all the tests have to fail, mind you, but every change should make at least one test fail. Now that's the upside, but as Fred Brooks told us back in 1986, there's no silver bullet. Besides which, those are for killing werewolves, not mutants. The first drawback is that it's rather hard labor on the CPU, and therefore usually rather slow. We certainly won't want to mutation test our entire code base. Got disco lights going. We won't want to mutation test our entire code base every time we save a file. Maybe over a lunch break for a fairly small system, or perhaps a weekend for a larger one. Fortunately, most of these tools do come with ways to tell, only bother checking this function, this class, this file, and so on. And most of them come with some kind of incremental mode. Oops. It's just taking a while to catch up. Hello. There we go, incremental mode, so that it can just look at what changed since the last git commit, the last time we ran this tool, or the difference from the main branch. Combining those filters, maybe we can come up with something that we can actually mutation test every time we save a file, or at least over a much shorter break. Another drawback is that it's often not at all clear what to do about the results. It tells us that some change to the code made no difference whatsoever to the test results. But what does that even mean? It takes a lot of mental effort to figure out what a surviving mutant is trying to tell us. It's usually saying that our code is meaningless or our tests are lax, but it can take quite a lot of effort to figure out exactly how. Worse yet, sometimes it's a false alarm, and the change might not have made any tests fail, but that's often because it didn't make any real difference in the behavior in the first place. And even if a mutation does make a difference, most programs contain a lot of code that we just shouldn't bother to test, like a debugging log trace. There we go. Fortunately, most of the tools have ways to say, just don't bother mutating this line or this function, this class, whatever. But that's usually with comments, which can clutter up the code and make it a little less readable. So how does this work, unlike this guy? Mutation testing mutates copies of our code, hence the name. And it does this with the intention of creating test failures, otherwise known as faults. So mutation testing is classified as a fault-based testing technique. And this means it's related to something you might already know about, Chaos Monkey from Netflix. But the way mutation testing works is sort of upside down from, go on, it'll get there eventually. It's upside down from what Chaos Monkey does. Chaos Monkey is best known for injecting faults like latency and jitter into Netflix's production network. There we go, just in time for the next slide. Yeah, production network. And if all still goes well, in the sense that Netflix's customers don't notice and their metrics still look good, then Netflix knows that their error recovery is working great. Mutation testing, however, injects semantic changes. It doesn't know if these changes, come on, change, are going to cause faults or not. We certainly hope they all will, but that's up to the test suite. And it injects them into copies of our code, not our actual network. And it does this in our test environment, not production. Whew. And if all still goes well, in the sense that our tests all still pass, that doesn't mean everything's fine. That means there is a problem. Remember, every change should make at least one test fail. Mutation testing has also been compared to fuzzing, a security penetration technique involving throwing lots of random data at an application. But mutation testing is sort of like fuzzing the code rather than the data, and it's also not random. But enough about differences. What does mutation testing actually do and how? Let's start with a high-level view. First, a mutation testing tool will break our code apart into pieces to test. Usually, these will be our functions. Then for each one, it finds the tests that cover each function and then makes mutants from that function. And to do that, it looks closely at the function to see how it can be changed. And for each way it can see to change that function, the tool makes one mutant with that mutation. And once it's done creating all the mutants it can for a given function, then it iterates over that list. It'll get there eventually. And then we get to the heart of the concept, which I'll skip to another slide. There we go. For each mutant derived from a given function, I have to look and make sure it's keeping up. It runs the function's tests, but it runs them against the current mutant rather than the original function. Now, most of the tools don't give us anywhere near all this information, let alone so neatly organized. But there's a conceptual model that I use to help explain the point. If any test fails, this is called killing the mutant, and it's a good thing. It means that our code is meaningful enough that the tiny little mutation that the tool made in order to create this mutant had a noticeable effect on the behavior of the code, and that our test suite was strict enough that at least one test would notice that change and fail. Then the tool will mark that mutant killed, stop running any more tests against it, and move on to the next one. But if a mutant lets all the tests pass, then that mutant is said to have survived. And that means it has the superpower of mimicry, skilled enough to fool our tests. Now let's peel back one layer of the onion. Whoops. Yeah, there we go, one layer of the onion, and look at some technical details of how this works. First, our tool will parse our code, usually into an abstract syntax tree, so that this code becomes this abstract syntax tree. Come on, plant the tree. Well, anyway, it's going to show an abstract syntax tree. I'm going to assume you're all familiar with the concept of an AST, but don't worry about actually understanding this one in detail. Then it traverses that tree, looking for the subtrees that represent our functions. And after finding one, it looks for the tests, which I'm going to completely gloss over how. Then it makes the mutants. And to make mutants from an AST subtree that represents a function, it traverses that, just like it did to the whole big thing. But now, instead of looking for even smaller subtrees, like twigs or something, to extract, it's looking for nodes where it can change something. And each time it finds one, then for each way it knows how to change that node, it'll make a copy of that function subtree with just that one little mutation in it. For instance, suppose our tool has started traversing this function subtree, part of that AST I showed you earlier, and it's gotten down to this if statement. For each way the tool knows how to change that node, it'll make a fresh copy of this whole subtree with just that node changed in that one tiny little way. After it's done making all the mutants it can by changing that node, it'll continue on to the next node and do likewise to that one, and so on until it's traversed the entire tree. It'll get there eventually. Now, I've been talking a lot about changing things, so what sort of changes are we talking about? There are quite a lot. It can change a mathematical, logical, there we go. You can see some of the reflection in the window back there. It can change a mathematical, logical, or bitwise operator from one to another, even going into a different category when the language and situation allows. For instance, in many languages, we can treat anything as a Boolean. So x times y might become x and y, or x bitwise exclusive or y. It can change the order of operands in cases where they matter. It could change a comparison from one to another. It could insert or remove a logical, mathematical, or bitwise negation. It can remove an if condition so that something that might be skipped over or done is always done. Similarly, it could remove a looping condition so that something that might be skipped over, done once, or done multiple times is always done once. It could change a value from its existing value to some other value, like changing 42 to any of these and many more, but I had to stop somewhere. It could even change it to a completely incompatible type, like changing a number into a, if I may quote Smeagol, string or nothing. Ah, somebody got it, thank you. There are many, many more types of changes, but I trust you get the idea by now. So let's peel back one last layer of the onion and look at some pseudocode that illustrates how this process works. We're not going to stop to inspect and unpack this, but the final slide contains the URL for all the slides. That's the same one I told you at the beginning, had the slides you can download. So then you can take a picture of the final slide and ponder this and the rest of them at your leisure. So now let's walk through some examples. We'll start with a simple one. Suppose we have a function like this. Never mind why, it just makes a good, simple introductory example. Think about what a mutant made from this might return, since it doesn't look like it would have side effects. Mainly, a mutant could return results such as any of these values, and again, many more, but I had to stop somewhere. Now, suppose we had only one test, like so. This is a rather bad test, but even so, it would kill most of those mutants, the ones shown here in crossed out green. But addition, multiplication, and exponentiation in the reverse order all get us the right answer. So a mutant based on those mutations would survive our test. Now, forgot to circle that. All right. A report from a mutation testing tool might present them to us as something like this. The exact format of the report will vary enormously depending exactly which tool we use. As you'll see later, there are lots. Now, the question is, what is this set of surviving mutants trying to tell us? Since our code is so short, it's quite unlikely to be redundant or unreachable code. So it's probably a gap in our test suite. So how did that happen? The usual cause is that the mutant returns the same value as the original function, or has the same side effect if that's what our tests are looking at. To determine how that happens, it helps to take a closer look at one mutant and a test it passes. So let's start with the plus mutant. Looking at this change together with our test makes it much clearer that this one survives because 2 plus 2 equals 2 to the 2. Come on. I'll get there. There we go. 2 plus 2 equals 2 to the 2. 2 to 2 to 2 to 2. And so does 2 times 2, but he's in the background. We can save him for later. So how can we kill this mutant? In other words, make at least one test fail when run against this mutant, but succeed when run against the original code? We need to make at least one test use inputs so that x plus y is different from x to the y. Fairly simple. For instance, we could add a test or change our unfortunately currently only test to something like this, asserting that 2 to the 4th power is 16. All the mutants that our original test killed, this would still kill. But also, 2 plus 4 is 6, not 16. So this kills the plus mutant. You see how that works? Okay. Even better, 2 times 4 is 8, which is also not 16. We devs should certainly know our powers of 2 at least that well. So this kills the times mutant as well. You'll find that killing one mutant often kills others as well. But the pair of argument swapping mutants still survive. But that's okay, we can attack them separately. No need to kill them all in one shot and be some kind of superhero about it. To kill the argument swapping mutants, we can, again, either add a test or adjust an existing test to maybe something like this. Asserting like this, ahem. Well, I'll just describe it anyway. Asserting that 2, there we go, to the 3rd power equals 8. If we reverse those, 3 squared is 9, not 8, so this kills the argument swapping mutants. But better yet, 2 plus 3 is 5, 2 times 3 is 6. Both of those are not 8, so the plus and times mutants stay dead, and we don't get any zombie mutants wandering around, even if this were still our one and only test. Hello? With these inputs, the correct operation is the only simple common one that gets us the correct answer. So this isn't the only solution. Now, there are lots of ways to skin that flurkin. Now, this may make mutation testing sound simple, so let's look at a more complex example. Hello? There we go. Suppose we had a function to send a message, like so. This function send_message uses send_bytes to send as many bytes as it can, looping to pick up where it left off last time until the message is all sent. A very common pattern in communication software. Now, a mutation testing tool could make lots and lots of mutants from something like this, but one of particular interest would be this. Removing those lines with the minus signs that I've dimmed. That'd be an example of removing a loop control. Now, suppose that this mutant does indeed survive our test suite. But even without seeing the tests, what would that tell us? If a mutant that only goes through that loop once acts the same as our normal code, there we go, as far as our tests can tell, then that means that our tests are only making our normal code go through that loop once. So what does that mean? You'll find that interpreting mutants involves a lot of asking yourself, so what does that mean? Often deeply recursively. In this case, it means we're not testing with a message big enough to make it go through that loop multiple times. In other words, bigger than send bytes can send in one chunk. So how did that happen? There are lots and lots of ways, but the most likely is we just didn't bother. For instance, we have a maximum chunk size of 10,000, and yet we're only testing with a tiny little 3-byte message. The obvious fix is to just deliberately use a bigger message. And with this assumed setup, we can make one trivially, just take the chunk size, add 1, make that big a message, and away we go. But let's look at another possible cause. Maybe we did test with the largest permissible message, or at least message size. For instance, here we have, well, we will soon have small and large message sizes. And we test with a large, there we go, and yet that mutant survives. In other words, we're still sending the message in one chunk. But what could possibly be wrong with that? What is this mutant trying to tell us in this scenario? In this case, it's trying to tell us that a version of send message with the looping removed will do the job just fine. If we remove the looping, and then everything that was there only to support the looping, we wind up with this. And now it's very clear what the ultimate message is, that send message may well be redundant and we can just use send bytes directly. Now in real world code, it might not be because we might have some error handling and logging and so forth that we need in send message, but at least the looping was redundant. Fortunately, when it's this kind of problem, the fix is very easy. Just rip out whatever it was that the mutant didn't have. This will also make our code more maintainable by getting rid of useless cruft that's just getting in the way of our understanding it. So now that we've seen some examples of spotting bad tests and redundant code, I'd like to address some common questions. First, this whole idea sounds pretty weird, deliberately making tests fail to prove that the code succeeds. Where did this bizarro idea come from in the first place? Mutation testing has a surprisingly long history, at least in the context of computers. It was first proposed in 1971 in a term paper by Richard Lipton titled Fault Diagnosis of Computer Programs. The first tool appeared in 1980 as part of Timothy Budd's PhD work. But it still wasn't practical on consumer-grade or even developer-grade machines until maybe about 2000 or so, with faster CPUs, multi-core CPUs, larger, faster, cheaper memory, and so forth. And that leads us to the other main question: why does it need so much resources? With some reasonable-ish assumptions about our code, we can guesstimate that mutation testing will often need about 200 times as many test runs as just running our test suite. So if our test suite normally takes a zippy 10 seconds, then mutation testing will take over 33 minutes. Yeah, well over half an hour. I don't know about you, but I don't want to sit there and wait for that. So to sum up, mutation testing is a powerful technique to check that our code is meaningful and our tests are strict. It's fairly easy to get started with once we understand the concept and have chosen a tool and configured it and so forth, but it's not so easy to interpret the results, nor is it easy on the CPU. And even if these drawbacks mean it's not very well suited for our current projects right now, I think it's still just a really cool idea in a geeky kind of way. If you'd like to try it for yourself, here's a list of the tools for many, many languages and platforms. I know it's much too small to read, but again, the final slide has the URL for all the slides, and by the way, a complete script, which I've mostly stuck to. But before we get to that, I'd like to give a shout out to TopTal. This is their logo. It's a consulting network I'm in. Please use that partly hidden, darn it, URL if you want to hire us or join us. The anchor part, accept only candid coders down there, tells them it's me, and if you actually do hire us or work a project through us, good try. Oh, well. Then we both get some bounty, yeah. And now here's that promised, here will shortly be that promised final slide with that URL for the slides and many more. And it'll be your turn for questions. There we go. Yes, the final word on that is slides there. Codas aureus, Reds, Mutants, Gambi, 22 slides. Okay, yes, a question.
Let me just grab the mic here so that everyone can hear from YouTube as well. And I'll go back and forth. Go ahead.
Okay, so I wanted to ask, what is the most common area that people use this kind of tool? Because particularly, I'm an iOS developer, and it's hard enough to make people care about tests. And the test is something even beyond that. So I would like to know if you use this in your daily job, and which areas do you recommend if I want to use this? Because honestly, getting it into iOS would be too hard for me right now, only myself.
Okay, I can just hold that by hand. Okay, if I understand correctly what the main question is, what sort of software does one generally use this on? Pretty much anything where the quality, at least the correctness and how thorough your test suite is going to be important. I would say most of the stuff that's visual effects on the front end, yeah, that's going to change with fashions and whatnot and isn't usually terribly important. But your business logic, anything handling money, that's where you want to make sure that your tests are strict, and this will help you with that. I can't speak particularly to iOS or other mobile development. I've only done a tiny smidge of that. Okay, next question. All right, I guess we're done.
Okay, thank you very much, Dave. Thank you very much, Dave. Well, until our next speaker gets set up, I'm just going to make some questions for the audience. I'm going to start with you. Do you want to participate? You don't? Who wants to participate? Maybe I'll ask Antonio again, because he was participating. So, hi.
Yes, hi.
Hi, it's Antonio, right?
Yeah, sure.
So you are, we know that you are 22.
20.
But we, 20?
Yeah.
Yeah, 20. But we don't know much else about you.
Yeah.
So what do you do? What
do I
you're
do?
here for?
Oh, I stood here at 42, above, right, on the
Yes?
upper floors. And yeah, that's pretty much it. I just study computers. and
Okay,
program.
so I know a little bit about 42 because I was a student as well. So how long have you been here?
So like, total like a year, yeah.
A year.
Yeah,
so-
but I started like 2 years ago, but then I stopped and then came back. Yeah.
Okay, so your main skills are C, C++, or something like that?
I would put it C, just the
Just
plus,
C.
it's too much, yeah.
Okay, too much.
It's too much, yeah.
And what else are you interested in?
I enjoyed the talk because like unconventional methods of programming and doing the work we do, right? Program, but in an unconventional way, I think.
Okay, nice. Well, I'm gonna go ahead in your friend right here.
Okay.
What's your name?
Israel.
Israel.
Yeah.
How old are you?
I'm 23.
So you are as well a student of 42?
Yeah, also.
So
But I have a question for you.
for me?
Yes.
Oh,
Which
nice.
project you stopped here?
Well, I started really early. I just concluded the first few rings because I didn't, when I got into 42, I got a job as well. So I had to focus on my job. And right now I'm working at Dashlane, a security company that makes a web extension and apps for iOS and Android for password managers. So I didn't actually study a lot at 42, but I have my profile there. If you go to the internet, you're gonna find me. It's C. Luis.
But you stopped
Dash Grow.
to study here, or you only pause?
No, the black hole got me.
Ah, okay. It's not good.
Not good, not good.
Yeah.
But yeah, it was a great experience at all.
What's your profile on? Intra?
It's C. Luis. Sorry?
Did you remember your profile?
Yeah, it's C. Luis. Go.
Ah, nice. The first scene?
Yeah. Not the first one. It was the second round of PCs. It was on August last year.
Nice. Thank you.
Thank you. Oh, I didn't ask. So you are also only C, or do you like any other programming
Yes.
languages?
A little bit JavaScript, but not so.
Okay.
Yeah.
Nice. Nice to know.
Nice.
Who else we got here? Hi. Can I interview you?
Yeah.
What's your name?
Sure. Hector.
Hector.
Yeah.
How old are you?
I'm 30.
So you study here at 42, or you just came for the GambiConf?
No, I came for GambiConf only, yeah.
So what do you do? What's your occupation?
Well, actually, currently I'm working on web development on a startup here in Lisbon that's called Cargo5. But actually, my passion is video games. On the side, I have my video game project, right? That it's based around like doing video games that tell good stories that help like the world and have something relatable for people, right? That are struggling.
Oh, that's
So
nice.
that's my-
That's really
yeah.
nice. That's really nice.
That's my project.
And
yeah.
so you said you're web development and also games. So
Yeah.
what are your main core languages that you use?
Well, for web, I'm working in Laravel mainly, so it's PHP with some Vue.js.
Yes.
And of course, some MySQL, I touch on everything because it's a big app. And for games, it's C#. Yeah,
Oh,
so
nice.
just Unity.
Well, it's
basically.
standard, right,
Yeah.
for games?
It's the entry point, right?
Oh, nice. That's really nice.
Uh-huh.
Nice to meet you, and I
Nice
hope
to
you like
meet
it.
Thank you.
Well, who else we get here? Can I interview you guys?
Oh, okay.
Okay, so what's your name?
Luis.
Luis. How old
Yeah.
are you?
I'm 21 years old.
21 years old.
Yeah.
Do you study here at 42?
No, I'm not studying here.
So you just came for the GambiConf?
Yeah, I came from Macabeus.
Oh, okay, you're friends of Bruno, okay.
Yeah, kind of.
So what's your occupation? What do you do?
Yeah, I'm front-end developer React.
Oh, nice, React. Me too. So,
Oh, nice.
okay, I have to ask this question. Do you use TypeScript?
Of course, TypeScript
course,
saved
of
our
course.
life.
Yes.
Today I work in a project that is right on JavaScript, and I want to die every day because all the functions don't have prop types, and I don't know what came from the API, and that sucks a lot,
Yeah, that sucks. And do you have any interesting project that you're working on?
Today, no, because I'm working on a company, but I'm studying new languages, new paradigms, So, but I'm not working on an interesting project now, but I'm studying a lot of new stuffs, new languages, just like Rust and blockchain stuff to enter in that new thing of technology.
Wow, that's really nice. I
Yeah,
really
yeah,
like
yeah.
blockchain as well.
Yeah, it's nice.
Do you have any monkey NFTs?
No, I only have the NFT from a guy from Brazil that call Fake Nichols, but I buy it
okay.
to help him and to be a part of the project, but I don't have any expensive NFT,
Okay, nice to know.
Nice to meet you.
Okay, we are ready. So our next speaker is a guy that knows almost everything about video. Please give a round of applause to Blagoy.
Okay, I think you can hear me. It sound good? Okay. Hello everybody and welcome to my presentation about video transcoding. So around 6 years ago, I had the chance to actually work on a project with the ultimate goal of converting proprietary format from surveillance cameras into standard format like H.264, which can be played by a player like VLC or Windows Media Player. The goal for this was to be used, for example, by forensic institutes. So receive this file from somewhere. They do not have the player, or they have it, but they have difficulties installing it. They would run through this software. They will get like a standard format, run it with Windows Media Player, and then identify the offender, take screenshots, and then, for example, either distribute among people, or let's say they run it through image recognition database. And once they find some information, they take the necessary legal actions. Before we start, a couple of words about me. So my name is Blagoy. I came from Macedonia. I work at Swiss company, etc., and I'm a tech lead of a team which develops applications related to a protocol which enables increased security during online payments. The easiest way to describe me is by 3 things that I really like, and that is traveling, running, and last but not least, coding. And now we can start first, of course, with the main concept or the main requirements of the system that we was about to develop. The first is the architecture. So by requirement, someone can upload like multiple files. We do not want to have just one worker and then leave the system hang out, but rather to have a distributed system with mixed nodes, and there is one server which will be like the orchestrator of the work. Then we would also need to have, for example, some kind of a health check, because in case some failure happens and you start losing nodes by nodes, at some point you would have a complete failure. And also we would need to have some kind of a dashboard so that the people using the software can track the progress, so how many files are in the pipeline, and until when the transcoding will be done. And now, first, what 2 kinds of operations we need. Once you run some file, first you need to determine whether you are able to transcode it. And this is a process of extracting something which is called the metadata. So here we will need to detect, for example, how many cameras are there in the video, what is the starting time, what are the name of the cameras, and stuff like that. Of course, what is the extension, the type, the codec. And the second one is to do the actual transcoding, if this is possible, so convert from one video format to H.264. And first, how do you start if you do not have any prior knowledge to transcoding? And the first one will be simple. So we say, if we have the video and also we have the player, then we could actually just do what a normal user would do. So we will start the player, then load the video, and then we will do something which is called screen capturing. This means that, for example, on periodic intervals, we will take like a picture, then we will convert it to audio video frame, and we will insert it into some output stream, so to create like the file that we want. However, there are some, let's say, issues with this, because at first it seems easy, but have in mind that we're talking about some unattended system. So first we would need to install the players. And usually, for example, when you install unattended, you have like one run, there you record the answers, and then you play again the installation wizard with those answers. However, if we're talking about some old players, there is a situation like this one, where we have wise installation wizard. And this wizard was that wise that it didn't even allow, for example, for you to change the directory that the player will be installed in. And this is like the basic thing. So we needed to give up on this, although we put like too much of an effort to actually have all the players on a common place. There was this site Code Ninja when this question was asked like 10 years ago without answer. So we hit the wall and we said, okay, this one will be left out of the group. But let's say this first step is done and you have the player installed, and then you're about to run the video. And then this first step is about taking out the metadata, and we say we will have some kind of a text recognition. And for that one, we used a library called Tesseract, which was supposedly, for example, if we provided an image with some timestamp, it would extract the starting time of the video. And this worked well, for example, with this, what I show here, but this is like level 1 because we have like monochromatic background and also rather really understandable like digits. However, we can have issues, for example, the font can be weird. Also, the background could be really hard to distinguish. We can have construct issues, then size issues, then there will be like rather strange format, then again constructing, And the last one, my favorite, so this last one is basically hard even for a human to distinguish what the timestamp is and not to train the computer to do the same thing. And now we say, okay, first we have, let's say, some kind of a player, and the basic rule here is that when you have some kind of a player, you would expect that this is meant to be automated, so that the developer of this software sends something like automation IDs. And then you would just fetch the control by automation ID, and you can perform some kind of actions like double click, drag, or whatever DOM events they are. On this first picture, we have like automation IDs, which is like the ideal case. On the second one, you think that this is like the same case scenario. However, you are wrong. Because first, you think that, okay, I will just fetch, let's say, the play button. I will change it to pause. Everything will work. But if you run this with some tools like, let's say, UI Spy, you will see that this is a pain. And this is like short for pain in the S. This is what your pain process will be. Because from automation controls, you have exactly nothing. And how do you deal with this? Well, first, you would need to take, let's say, this capturing rectangle. Then you would need to find the geometric center and then click half blindly between the center and the upper bound. Note the color of the target point before you click, and then to note it again after you click. And if this differ, this means that your click worked. And at first, this seems like too much of a work just for the only ordinary click, but it will prove that it is necessary, and we'll get back to that in a minute. And now we say, okay, we would need first to somehow see the video. And on this picture, we see just one black rectangle. The question is, how do we add this video? Or even better, where is the video here? It's very intuitive. And if you see here, well, here is the video. So this is like 24-hour format, and this small red dash is basically just a couple of minutes where we would have video. And how do you deal with this? Well, you would need to automate the process that actually would go through each of these cameras, and then you would need to automate the dragging from start to end. And once you drag correctly, there will be a video appearing to this. And this can be sometimes really a tedious process. However, there is some issue with this. And mainly when you are looking, let's say, for some criminal act, time is of essence, so you would need to act quickly. And in this case, when you need to do screen capturing, it's obvious that the best that we could do is like one-to-one. So the transcoding can take as long as the video is. And there are some videos which, for example, have like daily footage. And if you would need to wait like for a whole day for a video to transcode, this is a no-go. And we needed to ask for some other ways in order to make this work. And there is a possibility that some players offer, and that is like built-in video export functionality. So if you see here on the right-hand side, we have like export in H.264. This is exactly what we need, and this is something that definitely goes faster. Even if it is not our target type, we can, for example, get it into AVI or MOV, and then use like direct FFmpeg commands in order to achieve what we want. This for sure will be faster than like to do the screen capturing. However, not all the players offer this. And if this is not built in, there isn't much that you can do. So I mentioned previously that there were some issues, especially with screen capturing, but there are also some other more. Mainly, for example, if you have some images, you would need to rely on labels. And if labels are on a language different than the common one in programming, that would be the English, then you would have issues. For example, as we have more modern players, the choice of languages is really like high. And there are some other players in which, for example, here we can see that you are able to choose the language. However, there is like only one option, and that is German. And this would run you into problems if you define, for example, really the text that you need to compare against. And the other thing, which is even more interesting, is, for example, you would have sliders because really you would like to track the progress of a video. And in this first example, we have like a common slider, so here everything is working fine. However, if you see this example, again, the slider is kind of moving, but at some point it will stop. And then what you would need to do is basically to probe, because there is some invisible gap, in order to be able to continue. And if you need to automate this, having in mind that gaps can happen like throughout the video, it would be like really check the progress between two states, and once it stops, you would try, for example, to move like pixels on the right, and if you see some movement, then you start again, and then there will be like a second gap until you reach the end of the video. This is something that, again, it's a decision whether you would want to cover or just say, okay, we start on the first gap, but definitely if you want to be complete, you would need to put a bit more effort in order to handle these cases. It can be, for example, like from 100 cases that one is like this, but we say we want a universal thing, so we need to be prepared to anything. Also, there is another case, for example, like this one here, and if we see here, the label is actually moving. However, the slider is stuck at the beginning, so you have absolutely no information about the progress. And here the solution would be that you just take this label value on some consequent intervals, and then if there is a change, this is like a sign to you that you would need to still continue with the capturing. And also there are some other things. For example, the footage of the timestamp cannot be on the video, and then you would need like to manually add it. First to capture the frame, then to capture the label, and then to have a method which will write exactly a font bitwise on the picture itself. And the last one here, again, from what we see, this appears to be a standard slider. However, it's a picture. And now, again, the question is, how do you deal with this one? And it's, again, a matter of calculating with colors. So you would need to take like the whole rectangle, and then starting from the beginning, you search for green or greenish color. However, having in mind that this can be, for example, played on some kind of a virtual machines with different color scheme, you cannot be that strict, but you would also need to take care about the hue and the saturation in order to define like a feasible buffer, and then to say that you are fine and you can find where exactly the progress is. Previously, I mentioned that, for example, when you need about this player to note the color in order to see whether the click worked, when we do, for example, standard programming, we take things for granted. Let's say in Java, you add element to array, you do not afterwards check if it was indeed added. But this, when it comes to UI automation, is really, you need to be as paranoid as you can get, because the list of things that can fail is beyond your imagination. For example, we have this first example. You have some kind of a node where you would need to take the cameras, and you need to double click in order for it to expand. And that's what you do. You double click, however, it does not expand. So you would need to check whether your action indeed happened, because the click can fail. And it can fail randomly, and that's why you would need, for example, to try a couple of times with a given time threshold until you succeed. If you do not succeed, you give up, but however, you need to circumvent somehow these temporary hiccups. Or the other thing is here. For example, the video opens, but it's not at the beginning. We need to click like this button, go at the start point, and this will work, but it won't be immediately. It can happen about a couple of seconds later. And that's why, again, you would need to have like some waiting period in order to make sure that this is indeed what you want. Why we do this is because this is like a chain of events. And if something doesn't work as expected, then all the actions that you do afterwards are in vain. There is another thing. For example, you have like info about the cameras. However, if you select like one item, it wouldn't work. If you select as a group, then it's fine, which is like even weirder issue. Or let's say you have some kind of an export, and there you would expect that, for example, you have the pop-up, and there you track the progress of the built-in export. But this is again not the case. It can show like it's 100% in constant, and then you would need to rely again on some time interval in order to wait for this pop-up to disappear, and then you're sure then that you are at the end. So this is something that you really wouldn't find in convenient programming. There are some other issues, and the first one is, of course, that players are not ideal and they can crash. And if this happens and you do not have some kind of a mechanism to clean up afterwards, this would mean that you would have one or multiple nodes with hanging processes, and then this would lead again to eventual failure of your distributed system. So you would need always to check after you finish that the software process associated to this player is gone, or if it isn't, like to kill it forcefully. Otherwise, you would run into problems. And the last thing worth mentioning here is that in the beginning, we assumed that there will be a player that you can open the file with. However, if the player is not there, then all that we talked about previously is out of the question. And we would need to find some kind of additional thing to do in order to cover these cases. Also, the last thing is that, for example, if you want to do this in a commercial way, then you would need to care about the licensing. So this is like end user license agreement. No one reads this, but you would have to read it in order not to end up with legal issues. So as we see, the list of issues when you do things with the player can become quite large, and we would need to think about some other way that could save us both at least time and efficiency. And the reason for this is to use direct transcoding. And here I'm deliberately using like challenge because everything is challenge about this. The first thing is that you would need to deep dive into hex code because you do not have a player, you have a file, you have the raw content there. And this is also associated with lots of theory behind. We're talking about 500 pages PDFs, so about different formats, then coding of the objects, file structure, advanced video coding, and stuff like that. And this is something that no one would like to bother with, but would try, for example, to have a head start with something. And we, for example, what we did is that we have, let's say, some know-how about JPEG files or video stream formats, and we try to find that information. However, we have actually no idea how this is structured, so we would need to do a reverse engineering in the blind. But before that one, there is one thing that we unfortunately cannot do. I mean, we could, but it would be really painful, and that is that because we're talking about confidential videos, it's common that some of them are password protected. So what you could do here is basically, again, imitate what the user would do. If the user has the password, it enters it, and then we can open the video. But in the case if you do not have a file, this would mean that you would need to know the encryption mechanism and the secret key. Otherwise, you would guess, but there is no way that you could actually do the transcoding because the encrypted hex code is not plain. And this is what it's worth. For example, here we have a non-encrypted hex code, and here we have an encrypted one. And to someone that is seeing hex code rarely, this can seem like the same thing. However, there are some indicators which prove the opposite one. And as we see here, we have, this is like a hex code as a marker of starting of an image. And if we see at the bottom, there is like completely different numbers, and this means that the information is encoded. Another thing is that, for example, there were some situations where we thought that the video was password protected, but it ended up that it isn't. We had some player, and we saw that inside there are some .NET libraries. And there is already a decompiler provided by JetBrains called .pic. So we decompiled this thing. We saw all of the source code. We figured out that there is no password protection, and we went on with the direct transcoding. And the other funny thing was here that the player wasn't robust at all. So there was this method validate video file name, which was actually relying on the name that the hardware would export. So for example, here we have 4 names, and all of those are generated like by the hardware, by the camera. If you try to change some of this, for example, we changed the last one, we set it to test AVI, and then we see that even the player now does not recognize this as a video, although it is a full-fledged file. The other thing that we experienced is that, for example, even if you do the direct transcoding, there are some files which can have corrupt frames. And if you feed a corrupt frame into a decoder, it wouldn't fail as you expect, but rather we exhibit this behavior as we see here, so the picture is somehow transformed into an abstract art. The thing is that the video decoder is keeping some internal state, and if you feed it a corrupt frame, it messes it up, and it continues like that until the video stops. But the result is, yeah, pretty messed up. So once we finish with this, we say, okay, we'll just reinstantiate the decoder on every video chunk, and that's how we make sure that most of the video will be fine. Even if we find some corrupt frames, there will be like an interval which is not detectable to the human eye. And as you saw in this video, it's not like really dynamic. And after we fixed that, we wanted to see like whether it was worth and whether we will see something interesting. And as we see now on the next picture, the video continues to be like only the timestamp changing. But if you're persistent enough, you should see a pigeon appearing here, as you see here. So the funny thing about this is that when we are talking about these videos from surveillance cameras and people think like we are seeing crimes or something that is really, really confidential. And as you see here, we are happy if we see something like this. So it's most of the time just footage of something that is way, way boring to look at, but someone has to do it. The other thing here is that when we are talking about direct transcoding, usually we have some kind of a structure. As I mentioned previously, this structure all of the times is unknown to us. However, there is some rule, and we are talking about 4-letter identifiers, which somehow would need to describe what the author of the file format would do. Here we see, for example, the structure for MOF item, and here we define, for example, the headers, where the data is, and everything else. But imagine that instead of something which is rather known, you have like something completely unknown. You have these 4-letter words, which you have no idea what they mean, and it's like really as complicated as it can get. We indeed put quite of an effort to figure out or try to extract some streams, but it was hardly impossible, and again, we needed to give up. So we said, yeah, there isn't anything for us we could do. We put our best effort, but we couldn't make out to decipher what was meant with this file. So there were also this kind of cases. And the last thing that actually you would need to do in the first place is that you can't go away without diving a bit into the FFmpeg development kit. So warning ahead, we have some signatures of C++ methods, so there will be like a lot of pointers. In short, what you would need to do is when you need to have like a direct transcoding of the video, first you would need to allocate output context, then you need like to create a new stream where you would write frames, and then this AV codec open2 is basically the method which will allow us to open the codec with the given target type. Then we would use, for example, some frame that we will write data into it. We would need to open the input-output file that we will write to. And the last thing is that we start now with writing the header first. And the next thing is that we need to add frames to it. And we have like two things. One is if we have, let's say, a bitmap and we need to create audio-video frame. And the other one is we have like a portion of a stream. The easier way is to create like from a bitmap. So you need to make the frame writable. And then there is like this method where we actually transfer the data from the H bitmap into the AV frame with this method AV picture fill. Once this is done, there can be some incompatibility of the video format. So is this cryptic method SWS scale. So this is what would make you a standardized frame. And with this, you are done with one part of the branch. The other thing is that if you have, let's say, a video format, then you have this method AV codec decode video too. And what this does is it basically detects all the frames in it, extracts them one by one, and converts them to standard frames. And once this is done, you need to, for example, initiate a packet, and then this encode video too, which is the opposite to the decoding, would take this frame, put, let's say, video width and height to it, then also make a timestamp and define the frame rate. And with this last interleaved write frame is what we need to store the frame into the output context. The last thing here is, of course, to actually clean up mainly in the opposite way that we did at the beginning. So we wrote the header, we had the main part, now we will write the trailer and then start deallocating the memory. We close the codec, we remove the memory for the reusable frame, we close the output file, and we free the output context. In short, from what you have saw, there are like quite of methods. So the approach here is that whenever you need to do this, you just take some example, for example, either from the FFmpeg site or some code snippets on GitHub, modify it as minimal as you can in order to fit your needs, and then hope that you would never need to touch this kind of code again, be it for adding additional functionality or, God forbid, for fixing bugs. But in hindsight, I would say that the experience working on these projects was, especially in the direct transcoding part, it was like an emotional roller coaster. So at some point, when we were able to figure out how are things structured, and basically without knowing anything to create a file, we were like really happy. But at some points that I also mentioned, besides our efforts, there wasn't much that we could do, and we spent a lot of time. We tried different things, nothing worked, and we said, okay, we give up. We were a bit frustrated, but all in all, it was like really fun because this project was unconventional and it was way different than the standard corporate work. And with this, I would conclude my presentation. Thank you. Do we have any questions? Yes?
Just the mic over there.
Hi, my name is Hector. I wanted to know that about, in your perspective, what applications do you see for this project? If somebody was crazy enough to pick it up and trying to build on it to make something reusable or at large scale, what applications do you see for this kind of project?
Yes, so this is something that I already mentioned because this was a use case that would be used by forensic institutes. So the thing was that, for example, there are like multiple institutes which are connected between each other. And one institute sends to the other a file. And now this institute, for example, does not have the player, or it has, but it's an old one. It needs to be installed or on Windows XP or I don't know, 95. And then they need to deal with this. And they want, let's say, in a couple of minutes or let's say hour at most to find image of offender in order to react quickly. Otherwise, if this takes like a couple of days, especially if this needs to be distributed among people, like nothing will happen. And that was the main use case that we did. Okay. Other question? If not, then once again, thanks for listening.
Thank you very much, Blagoy. Well, now we already have our first half of our talks. Now we're going to head into a coffee break. And if you want to just say something or if you want to talk with the public, by now we're going to have a coffee break on the live stream. So people will not be seeing the screen and in the place. But if you want to talk, let's eat. Once again, thanks for Reactor to sponsor this coffee break. It was really nice from them. And, well, let's chat, let's eat, and build our network together. Thank you. Oh, important thing. We cannot eat on the carpet. We need to eat outside of the carpet. So there is a kitchen place over there, so we can get together and eat there. So we don't put some scrums inside the carpet. Thank you.
Desliguei o microfone um segundo antes de fazeres isso.
Eu espero que tenha.
Deixa
Não, deixa aí. Okay, só tenho que pegar aqui a imagem do campo.
E aí, mano, beleza, cara?
Beleza.
Você vinha aí?
Obrigado.
Pô, velho, desculpa aí que você pediu uma talk lá, mas foi
Não,
de muito
relaxa.
última hora, cara.
Relaxa. Não, porque foi de última hora que eu soube que o palestrante perdeu o voo também.
Foi o Edu, né? Que perdeu.
Foi o Edu.
Porra, eu vi ele.
Sério,
falar,
tô...
Que tristeza.
Eu ia fazer uma foto, Você me fala uma semana antes, a gente apresenta qualquer coisa. Mas, mano, força, tá muito da hora aí.
Ah, ok, obrigado. Eu só tenho que fazer aqui colocar aqui a imagem na live. Ok, porque coffee break. Cara, o meu costume de OBS é muito ruim, porque assim...
Aprendendo no trabalho.
Tô aprendendo quando eu tô fazendo aqui, na dúvida. Ok. Eu não sei porque não tá com a imagem do background aqui. E aí?
So hello everyone and welcome back to our second half of talks. Right now we're gonna have a talk from Tang. But first, I'm just gonna ask again the public here. I was about to ask you, do you want to participate or not?
Yes, I can.
Okay, I have only a simple question to you. First, what's your name?
Lucas,
Lucas. How old are you?
you can't escalate.
Okay. Okay, on the early 20s.
Yeah, so something like that.
Okay.
28.
So you study here at 42 or just came for the GambiConf?
Yeah, I'm with my friend Luis. I'm living in Porto, so we came for a show and for this event today.
Okay, nice. And my question is, what was your first gaming console?
It was a Mega Drive.
Mega Drive.
Yeah.
Okay. Have you ever thought of like reversing engineering a Mega Drive?
Oh, sure. I always wanted to know how to do it, so it's a very nice subject to watch right now.
Oh yeah,
I'm
and
very interested.
in our next talks about reversing engineering, a Game Boy compiler with Ton. Giving a round of applause for Ton here.
Perfect. Yeah, my first gaming device was a PlayStation 2, unfortunately, and I didn't own a Game Boy until starting this project. So, yeah, I'll be talking a little bit about, I guess, reverse engineering a Game Boy or writing a fourth compiler for Game Boys. A bit of both, I suppose. But I can start by introducing myself briefly. My name is Tijn. I work for Reactor at the Amsterdam location. Kind of visiting this week at the recently opened Lisbon location. And I guess like my regular job is doing software consulting, mainly writing TypeScript or some sort of like React or JavaScript during the day. But yeah, I guess like a couple of years ago I started a sort of an after hours hacking club at work, or kind of like after work, with kind of the idea of like doing like some fun projects that are, you know, not necessarily useful, but kind of like diving deep into something that you typically don't get paid for, I suppose. And like not focusing on any sort of like useful tech, but just kind of exploring our curiosity and kind of seeing where we end up. So for our first project, we kind of like thought, let's do something on Game Boys. Like they're kind of fun devices. I never owned one, so good excuse to kind of invest in some new hardware. And yeah, and I guess initially we figured let's write a game for this device, which is I suppose nowadays like rather easy. And then kind of from there we figured let's do something a bit more complex than just downloading a C compiler to Game Boy. And like we figured like let's make our own programming language kind of from scratch. So I guess like a little bit about the Game Boy hardware. I guess it's a quite old device. It doesn't do like super much. It's quite slow compared to the usual computers that we work with nowadays. But that also makes it like super easy to, or like rather accessible to kind of reverse engineer, because there really isn't like much going on. And I guess like the standard ROM size is like 32 kilobytes, so it's kind of easy enough to do by hand still. So I guess like documentation on Game Boys is kind of readily available. Kind of the official docs are leaked, I suppose. And there's a lot of like community support on kind of like all the caveats and kind of like weird undocumented features basically. So like there's a lot of like stuff you can read online already. But if you kind of go through it, you will see that's like kind of starting from scratch like gives you like a really long feedback cycle. Like you can't really get something exciting on the screen to start. You have to kind of read on like how do the header files work, like how do the checksums work. Basically all the stuff that you need to kind of just start a Game Boy ROM. And yeah, it takes like forever before you see anything on your screen basically. So we figured let's reverse things and start with a sort of example game. So we kind of like Googled a little bit and we found I guess like a Hello World Game Boy ROM, which does not much but just like shows Hello World on your screen. And we figured like let's kind of like incrementally kind of like reverse engineer this ROM into something more interesting. Then a little primer on Forth. I don't know if anyone is familiar with or has used Forth. One person, kinda. Oh, wow, okay. 2.5 people, I will count it as. So I guess like Forth is a nice language to kind of do this sort of stuff with. It's a very simple language, I guess like a little bit more complex in assembly, but it provides like almost no real like language features or syntax. Basically, it's a stack-based language, which means that like all the arguments are just passed on like a central stack, and the language is like concatenative in nature, which I guess like we'll see kind of like what it means in practice a bit later. But essentially it means that like kind of reading it is as simple as, executing tokens from left to right. So kind of like example code here to kind of illustrate this. You see like basically numbers and other things. Basically the language doesn't distinguish between any, reserved keywords or anything like that. So basically like when it sees a number, it pushes it on the stack. When it sees anything else, it kind of treats it as a word or like function in other languages, I guess. That it just like executes and it kind of takes parameters from the stack and then kind of adds stuff on the stack. So this program kind of like adds 2 and 1 together and kind of prints it to the screen. Then of course like kind of like creating new definitions is also possible. I'll not go into too much detail here, but basically the colon and then kind of semicolon kind of define new words. So you can basically rewrite the earlier codes by kind of like creating this like increments word that essentially just like adds 1 to the parameter stack. But let's look at something more interesting. So, like I mentioned, like the first kind of like ROM that we started with was this Hello World ROM. You can kind of inspect the raw bytes, and you will see this in the hex editor basically. And doesn't do much, of course, but it's kind of a working ROM. So really like our first kind of like target of like what we're trying to achieve. And I think like the first version of our compiler, if you want to call it that, was simply kind of like adding one word after every byte. So this is a valid Forth program already that kind of just like emits all the bytes to a file. So like the C, word here is a word that basically like takes a number and outputs it to a file. And that's all of this, and kind of this is the I guess first version of our kind of program that like generates some sort of like ROM. Then doing a little bit of research. This probably like doesn't look like much here, also not to me, I'll be honest. But kind of like looking up like some like offsets in the header structure, you'll kind of find that some ranges of bytes they kind of indicate the red part here is the Nintendo logo if you look closely, and the blue part here is, for example, like the title of the ROM. It's not really visible, but it's kind of something that Nintendo uses internally. And I think like this is like the first step where you kind of see this like concatenative nature of Forth being like super useful, because it basically means that refactoring is super simple. Like you don't have to like rearrange anything. You can pretty much just like copy paste, I guess like series of words and numbers into like a new definition. So this is kind of the first step of destructuring these bytes into like something more sensible. And you can see like you can kind of give a name to things, and it kind of slowly but surely your file becomes human readable to some extent. There's still a lot of like binary going on, but I guess like all the data is kind of extracted in its own definitions, and you can kind of make sense of it at least. Then I guess after this, you kind of like at some point you're left with a lot of like bytes that you haven't like decoded yet, because like the most part of the ROM is of course like your program itself. So this is like operation codes basically, and to kind of like decode those again. You can kind of do this by hand. It takes some time, but it's kind of like pretty easy, I guess. It's mainly time consuming. So you can kind of like find like tables of like all the operation and kind of assembly instructions of the Game Boy chip. This is like almost all of them. I guess like there's a extended set still available. But to kind of illustrate like how kind of decompiling here works, I can look at 3 of these specifically. So we see the inc A, B, and C, basically like a CPU instruction to increment the A, B, and C register by 1. Very, very basic, doesn't do much, but it's kind of like used internally, of course. And yeah, it basically means that like you can kind of look up like what are these like, byte values mean, how to kind of translate these to something that's more human readable, and can kind of create your own macro language, like if you will. So basically you can slowly like decode all of the numbers into like some human readable format. Then going a bit deeper, because of course like this is not super interesting yet, looking a bit like deeper into the bytes, you can kind of start to recognize some like patterns in the bits. This is also like quite well documented, to be honest, but basically you see some similarities within the like different operations, and kind of like, you know, incrementing A, B, or C is like there are some similarities. So you see in red, like basically the register value is given in a few bits, and kind of the operations is given in like the remaining like 3 bits on the right. And that's interesting because that kind of allows us to like extract those common parts, right? So basically you can kind of like extract the part that kind of means like increments, and the register values like separately, which means that you can kind of extract that. You can kind of extract all of the words into something that like makes a bit more sense. So basically, incrementing can be done with like different parameters, and again, like basically because of like the fourth language is like, you know, like concatenative in nature. You can kind of just extract like former words into like new words without really arranging much. So this is all like equivalent to each other. It kind of like leaves you with, you know, something where you can replace all of these like raw bytes that like don't mean anything to something that's, you know, if you're a bit used to like assembly, is like more or less understandable. Right. Then many hours later, you can kind of like create something like a bit more interesting even. This is a screenshot from the source code. This is basically like implementing the assembler of Game Boy chips in Forth. I think like good to mention here is that like Forth is so like, you know, free form basically, that kind of allows you or almost like kind of forces you to kind of create your own language on top of it. So here you see kind of like something that kind of resembles a bit of a programming language maybe, but it's really like something that you kind of like build on top of primitives basically. So like I won't go like too deep into this, but this basically means that we can kind of like define instructions like increments and do some like interesting pattern matching, so it kind of generates the correct bytecode eventually. Anyway, all that work results in kind of like the bytes that you saw before to be transformed into this. So this is kind of like the same Hello World example, but in I guess like fourth assembly, and this is like, well, not to me super readable maybe, but at least like you can like do something with it, and like this is something that you can kind of understand what's going on if you like take a close look. And I guess like this is basically the point where we were able to, you know, modify the source codes and then kind of like, you know, print your own messages on the screen, like not much else still, but like it's kind of like a nice starting point at least. And I guess like it's nice to mention that like, you know, at any step of this like process, the Hello World example is basically still working, right? So every kind of like word that you move over or decompile, like the source code stays the same. So you can do like quite simple like unit testing or like snapshot testing actually, to like ensure that like everything still works. Then next step. So at this point you kind of like decompiled all of the, you know, assembly instructions into your own assembler. Again, this is a quite like easy process. It takes a lot of time, you know, because there's a lot of bytes to decompile, but essentially it's quite simple. But then kind of like next steps is kind of like, you know, we figured, what do we do now? Like, do we write something in assembly, has been done before, or do we build like a language on top of this? And of course we opted for the latter, and like we figured like let's implement a simple Forth compiler that basically compiles Forth codes to a format that the Game Boy can run. And then after that we can consider like, you know, adding useful libraries and like creating some games on this. So first step is writing a Forth compiler. That as well, because of the simple nature of the language, is actually quite straightforward. If you look at the source code that we ended up with, it's like maybe a little bit complex because there's some nice extra features in there, but essentially like a Forth compiler is fairly simple. One thing you need to do is like, you know, take a piece of memory in the Game Boy and kind of assign it as a stack. You kind of keep track of you kind of keep track of like where you like puts parameters in basically, and then I guess like I mentioned at the beginning of this talk, like Forth only has like two constructs. One is a number, the other one is a word. So like basically what you end up with is having a word to compile literals. So basically like adding a number to a virtual stack, which you can kind of see here. I'm not sure how familiar people are with assembly, but it's at least very short, so you kind of will get through it eventually. And the other one is basically like compiling words, which means that you look up like a word and then kind of compile a system call there. Then after that, basically we started writing a core library. I guess like these are quite primitive words, so kind of like the first words you implement, of course, in any language, you have to kind of like start in assembly. So you see here kind of addition of, I think like two 16-bit integers. The Game Boy only has like an 8-bit processor, but you can kind of like, of course, like try to jungle some numbers around and eventually can kind of do like 16-bit arithmetic. So I guess like early days of this project was a lot of like assembly programming, basically like making a lot of like basic words, but like surely, but slowly but surely you kind of start, you know, adding abstractions on top. So like eventually you can kind of combine these words in Forth, not anymore in assembly, and you can create like quite complex libraries on this. And again, the kind of example that I showed in the beginning, this hello world is kind of like rewritten in this. This is the entire file. So we have like libraries to kind of simulate a terminal window basically. So it kind of like allows you to like print text on the screen and position it at a correct location, and have I guess like the IBM font is a quite standard font that's included in a lot of like Game Boy toolkits as well. Then I guess like next steps is kind of like making this more useful. I already mentioned like with this like terminal emulator basically fonts, but also kind of like managing inputs, some utilities for the memory, but also kind of like making music and playing sound effects basically on a Game Boy. Essentially me just like writing, you know, certain byte values to certain locations in the memory. So you kind of can create like abstractions on top of that to make it a bit more usable. So you can basically like play music like in a way without like having to understand how does the memory basically look like. And yeah, I think like on top of this, making some games. Top left you see actually quite interesting implementation of Sokoban, originally made I think in like 99 if I'm not mistaken, or maybe even like 97 for GeForce. That was kind of like source code included, and we managed to port that with like I guess like minimal changes. I think like we need to fit it in the screen size a little bit better because the Game Boys have a quite small screen. But basically like managed to port like a fourth game like to the Game Boy with like changing maybe like 5 lines in total. All right. And I guess like all of this is open source. If you want to check it out, gbforth.org contains the project. You can run it quite easily, also in Docker for people who don't want to set up GForth. It can be quite tricky, I think, on Macs at least. And yeah.
Somebody has any questions? Nope. Okay. Thank you very much, Don. And before our next speaker, I'm just going to make another question as always. Guilherme, can I ask you a question? Okay, let me go over you. So yeah, just to use a question, how old are you?
26.
26. Of course, you don't study here at 42. You just came for the GambiConf, right?
Yeah.
And what's your occupation?
I work as a software developer at Reactor.
Oh, so you are Tan's colleague?
Yeah.
Okay. And my question is, what's your relationship with CSS?
Yeah, I think I know CSS, but mainly I just Googled it to center a div or something like that. Yeah, it's a passion and anger, I would say.
Passion and anger.
Yeah.
So, of course, you know how to center a div, right? By heart.
Yeah, I
You
think
sure?
I know, yeah. No, I'm not sure.
Okay, well, I too don't know how to center a div. I think I should, because I'm a front-end developer, but well, we can have Copilot for that, right?
For sure, yeah.
Okay, so, well, CSS is of course the most difficult problem inside software engineering, more difficult than machine learning and nuclear science. But we have somebody over there that over-engineers CSS, and is going to bring a talk about the amazing things that we can have with JavaScript and CSS. He's setting up his things, and I'm just going to go over here and ask some other people some questions. Can I interview you?
Yeah.
So what's your name?
Rodrigo.
Rodrigo. Do you study here, Rodrigo, at 42?
No.
So you just came here for the GambiConf, right?
Yeah, exactly.
How old are you?
36.
36?
Yeah.
And what's your occupation?
I'm software engineer in the Cloudflare.
Wow, Cloudflare. So if you push a merge request, the whole internet goes down, right?
Not necessarily. It's not my
Just kidding.
kind of product, but yeah.
And what do you do inside Cloudflare?
I'm working in the app clients for the 10101, the DNS resolution, and working the enterprise products.
Wow, that's really nice. That's really nice. Cloudflare has a really nice reputation. So you're basically a hero inside the software engineering world.
Depend of the perspective. Yeah. Yeah. For some heroes, for others, a villain. Yeah.
Yeah. And what's your relationship with CSS?
I don't work with CSS in the last 10 years because I moved for the iOS development.
Nice.
Probably the CSS is a great reason for move from the web.
Yeah, I agree.
Yeah, I don't have time to follow all new frameworks from CSS and JavaScript, yeah.
And is Swift UI any better?
Yeah. Swift UI is better. Have some concepts from the CSS and the idea for the components and the render components and the React states. But don't have a description language for style. And that's the reason for me it's more easy. You don't need to learn a new language for style or components. It's basically everything is Swift.
Oh, that's nice. Well, just a trivia, my first programming language that I really took seriously was Swift in 2015.
Wow. My first language was Pascal.
Pascal.
Yeah, with 15 years, I started my college, learned Pascal.
So if I'm doing my math correctly, when I was born, you were doing Pascal.
Sorry?
Yeah, when I was born, you were doing Pascal. That's really nice.
Yeah, probably. I started very early, yeah.
That's nice. That's nice to know. Well, I think our guy is already here. Well, give a round of applause to Dave, our next speaker. Where's my, oh, he's there with Guilherme. Thank you very much, Guilherme. Thank you.
Would you like to start?
Presentation.
Cool. Thanks for the applause. So yeah, thanks for having me. Today I want to talk a little bit about a story of a project I created during the confinement, hard lockdown in Spain 2-3 years ago. And yeah, the title of the talk is like how to mimic a JavaScript feature in a strongly typed language like OCaml and over-engineer CSS. So it mixes two of my favorite topics, which is like a strongly typed language and CSS, which they don't have nothing to do, but you would see today that they eventually do. So I'm David, I'm from Barcelona. I work remotely at Ahrefs. It's a SEO company that we provide a tool that most SEO marketing teams, they pay us basically to rank the website, to understand the campaigns, and to do all sorts of SEO things. Before that, I worked at Typeform and Draftbit, so I have been working for startups a long time. And I create a few open source projects and I maintain them. And today we're going to talk about styled-ppx. So back in the days, I used to work in Typeform doing React. I was part of the team that were doing the form. So like all UI, all the front-end logic was on our team. And just to give a little bit of context, that's where Facebook released React, or like 2 years later, and then like they start promoting some sort of like breaking the best practices. So one talk of Peter Hunt where tries to get rid of the monolithic approach of your HTML for the presentation, the CSS is for the styles, and the JavaScript for the behavior. And the other talk that was very interesting as well was from Viju, I think. Well, it's a French guy from React at the time that introduced CSS in JS. So the first concept that stuck with me a lot was that at the beginning you were doing all sort of front-end stuff where you could render the HTML and add a little bit of CSS and a little bit of JavaScript, and you would have your website. And the best practice at the time was you must have a file for each thing, and you would never, ever, ever would put like mix those, right? That was like a huge mistake. That like if you do a pull request with those changes, it would not get approved. But somehow Facebook and the mental model for React, they challenged that. They said that every component should be like isolated and should contain the three of them. They introduced GSX, so now the HTML is now as well like the component. They put the JavaScript inside, and that was like the time for putting the CSS inside, right? So the kind of like the technology or pattern that was called CSS in JS, right? One of the problems when you do CSS at large scale, and even had that at Typeform, is that you would have like a huge amount of CSS that nobody owns. It would grow forever, and you would never ever feel safe to remove anything because you wouldn't know if that change would affect all your application. And if you do those changes, it's going to be a nightmare to debug. So the good things about CSS in JS is that allows to write actual CSS. So there's no layer between what you write and what's going to be in the browser. It's all the global namespace, right? In CSS, any class, any ID is going to be global. So any, for instance, Chrome extension can override your CSS, for example. Or any small piece of HTML can break your website. The other good thing about that is that you could use JavaScript to enhance the limits of CSS. For example, you can style composition. You can abstract some common logic, right? The other thing is that you could share, of course, tokens and variables between the two languages. And it's very easy to predict when your CSS is coupled with your components. As soon as you remove a component, you know for sure that it's going to remove the CSS. So it's very predictable. The other thing is that it's very easy to remove the styles because those are coupled together, right? Two of the most famous back in the days were style components and motion. They introduced the pattern of the styled tag. So you would create presentational components just by giving the CSS, right? You would see here that the CSS and your JavaScript lives on the same file, right? And you would create those components based on these tiny little CSS definitions, right? Before getting into, like, just to give a lot of context, for someone who never saw JavaScript maybe or never have experience with it, let's break down a little bit. So this syntax that I described here, it's called template literals, right? Template literals in JavaScript, you could have a string, which is a double quote normal string, as most programming language, I guess. And there's another syntax introduced like a few years ago called template literals, which is with these backticks, you can have interpolation much cleaner than before, which allows some sort of like magic trick, I guess, some sort of like syntactic sugar, where you can call a function with a template literal, and those strings interpolated are going to be like an array in your function call, right? How the CSS in JS underneath works, it's kind of like the whole magic of it is that every component at compile time, or depends on the library, but most of them are compile time, it would generate a hash for all your CSS, and as soon as it renders, it's going to inject on the header the actual declaration, and each element is going to be assigned to this class name. So you are sure that it's not going to have any collision with the rest of your style, and you could have as much components you want, and as soon as you reuse some styles, are going to be added to the head, so you are fine. One of the things that I like the most about this approach is that when I give a design, or when I'm working with some designer or whatever, I like to think about those small components. So my head always maps perfectly what's on the screen and what's on my code. So I rarely open the browser to see what's inside, right? So like every piece gets mapped perfectly with the JSX, right? That's one of my favorite features. So yeah, that's a nice little animation. So one problem with JavaScript back in the days is that it's a loosely typed dynamic language. So we all kind of like, if you have experience with JavaScript, you already know what are all those problems about. I'm going to explain precisely what happens with CSS and JS problems. So the idea is that you would have a link component and a primary prop, right? So you can pass the Boolean primary true or false, but accepts, of course, undefined, integer, or whatever. What happens with this API is that you could easily assign this prop as a value on CSS, right? You can as well like call a function from that value, right? So you have a runtime on your CSS, that's fine. But you can as well have a prop that changes a property of CSS. That's as well really valid, but it can cause many, many problems. It's very common in your application. If you keep doing that forever, you would end up like this, right? You're going to have like whatever property you're trying to define, but you define pixels, right? That's fine for the browser, because the browser is not going to complain at you. You're just not going to see that error. One of the good and bad things of the web is that the CSS it's not safe. Like it's failure proof that anything is not going to look as you expect, but no one is going to tell you, right? So it's one of the most powerful things, I guess. But of course, if you're working in a company that you have like I don't know, hundreds of engineers working on it, this is going to be like a nightmare, right? During that time, I was, because of this React model, I got introduced into functional programming. So React pushed for immutability, push for pure functions, and I was very intrigued with all the mathematical background that I have, what's all this model about. So I started playing with Elm. Elm is a functional language, comes from Haskell, and it's beautiful, and it's just for the browser. The other language that I got introduced to is Reason. Reason is the language that this project I'm going to talk today is written about, but for the ones that you don't know, which is mainly common, what's Reason, right? Reason is a functional, strongly typed programming language derived from OCaml. Okay, what's OCaml, right? So OCaml is a very old language, comes from the Lisp, standard, F# languages. Of course, has all my favorite features. So it's immutable. It's performant because it's meant to compete with C or C# or C++. Performance is safe, so it's strongly typed. It's practical in the sense of it encourages functional programming, but it's not as strict as Haskell. So you can get things dirty done when you need to. And that's kind of like one of the good balances I see of the language. And as well, one of the key features is that is inferred. So you don't need to go to all the type definitions or go to all the functions or go to your model to type. The compiler is smart enough to guess which types are you using. And of course, are optional, so you can enforce the types, but most of the time you don't need to. So yeah, it's for the ones that you have experience with TypeScript. TypeScript is like, I would say, half of the smart of the compiler of OCaml, where TypeScript sometimes infers properly, but fails miserably most of the times. You would not have this experience with OCaml. Another more things about OCaml, just in case. It's barrel tested, so I think it's 20 years old. And was thought, or at least it's very used in many fields to write a parser, a compiler, a formatter, anything that kind of like touches an AST. I think OCaml is the best language. I think Flow is written in OCaml. The Rust started as an OCaml project, and Hack, I think it's in OCaml as well. So like most compilers, or at least the people who come from a CS background, they're going to start with OCaml. Has the decent tooling, the compiler is fast and good messages, and it's a decent package manager. And one of the nice things about OCaml is its portability. You can compile to binary, interpret it, or to the web. So you can really distribute OCaml everywhere. And you are in a good company, right? So like those are the big companies that are present on the website that we use OCaml in production. So going back to Reason, was just a project from Facebook as well, from the same creator as than React. And the idea is that, okay, let's bring all the good compiler part of OCaml and to make it look like JavaScript, so we can like have all the manpower of JavaScript that comes with it. One of the key things about it is that you can target the browser. So it was very easy to adopt. Reason, of course, comes with React built-in, so you don't need like a library, kind of like the compiler understands React. One disclaimer is that the Reason and Backal script, like the compiler that goes to the browser, was rebranding, I think was like August 220. Yeah, like last year, they rebrand into Rescript. It doesn't really matter. Like I'm gonna talk about Reason, OCaml, or Rescript interchangeably during this talk. If you have doubts about it, it's fine. Like it was a mess. Now it should be gone. But of course, like I'm gonna mention Reason a lot, so I needed to put a disclaimer. So let's go back to my journey. So I was very interested in the CSS in JS kind of like pattern or way of working, but I wanted to discover that in Reason. So I already left my previous company. I joined DraftBit at the time, and they were using Reason in production. So I was like, how can we use CSS in JS? Is CSS in Reason? Did I invented the term? Well, it was a little bit silly, but turns out that many people, when I look at it, many people were asking that. So there's definitely an interest. And I thought, okay, see, if there's so many people interested and the community is very bright and smart, why nobody kind of started this? So I thought, okay, maybe should I? But I don't know. And then the solution that came up very early are bindings to the CSS, which means you'd write all the spec of CSS, or at least try to all the common properties from CSS. You would turn them into functions, all units, so pixels, rems, percentages, everything is going to be a function, and all values should be, all CSS values should be Reason values. So you would write with some sort of DSL that it feels like CSS, but of course it's not, right? So you can have all the good things about auto-completion. You could have error messages. It's going to be type safe. But again, you would need to learn this DSL. And if you are handling that to a designer, they're not going to understand at all. And one of the things that you would lose is the JSX that I mentioned before. Like here, I cannot see clearly what's what, right? Like I don't know, that's very hard to parse mentally compared to the previous version, right? Here are, of course, some of the good things. But the bad things, the worst cons that I found is that there has no integrations with the DevTools. So I can go to Chrome, play around with CSS, go back to my browser, and keep looping. I need to translate it to in this pseudo language. That's the most annoying part. And of course, you don't have the Copilot, right? You don't have integrations that get out of the way. So you are not using the platform. You're just using your own invented language. And I really wanted to write CSS. I've been I think, doing web for 10 years, and I'm very used to all the patterns, all the tricks, and I just wanted to use CSS. But one of the biggest problems with Lisbon is that the templates literal, the feature that I explained before in JavaScript, doesn't exist. So I was like, okay, there must be a way. Like, it's not possible that it cannot be done, right? It's just a language, right? And then adding most of the reading most of the blog posts that I have read from OCaml, I read something which is ppx, right? It's a preprocessor extension, and I'm going to explain a little bit what it is. And I think, right, yeah, it's the solution that a compiler gives us to extend the syntax, right? The people who works in the compiler, they don't care about your problem about syntax, so they provide this way to extend the compiler. It's very useful for support your DSL, like this example. DSL is like domain-specific language. It's like whatever language that you want to write. Is well like very useful to generate boilerplate, so you can add these ppx's to generate like encoding, decoding, transformations, debugging, logging, all of this. Is well like very useful to performance. Sometimes you can add another ppx that does tile optimization. You can recursive early, and you can do like all sorts of like good problems to solve from what you couldn't do with code. You could do it at compile time, right? I'm gonna explain what preprocessing means in a second. And yeah, the last one is that you can add metadata to your code, right? At the end of the day, you feel like writing a ppx is kind of like a magic. It's like half of things you don't understand because you are really getting deep into the compiler, and you have no clue how the AST of OCaml works, right? So the general idea, just to get you into the concept, the compiler gets your source code as plain text and transform into parse tree. Parse tree is the same structure as Dave showed before, which is like a tree of all your nodes as code, and they are connected. And then it sends it to all the ppx that you're using. The ppx gets this AST, do some sort of transformation, and keeps going with the compilation, right? At this point, you are like in your ppx, what you get is AST, which doesn't contain any types, right? After the compilation step, you have these types. So you are working almost with text, right? The general idea is that ppx is a function that gets AST, needs to generate valid AST, right? It's very important that you generate proper AST, because if you have not a syntactic error, it's impossible to get a syntactic error, but if you do something that lexicosemantic or lexical meaning is broken, you wouldn't know, right? And those issues are very hard to debug. You can think of them about like some macro systems. So I think the most common one, maybe if you're from frontend, is bubble macros. But yeah, that's kind of like what we have in OCaml, right? Another, like a few examples. These are like the top is made up, but the bottom is GraphQL. So same example, you want to embed your GraphQL queries inside your reason files. Of course, OCaml doesn't support GraphQL natively, so we have some person implement a GraphQL ppx, so you can support GraphQL. Right. So once all of these came out and I understood all the concepts, I thought, okay, we have a syntax. Like I think the idea can work, right? So that's very similar with the JavaScript syntax. It's just like a module. The first styled-ppx component, that's a component in React, and this element is a div, and this has the styles. That's kind of like very easy to translate, right? Once this happened, I started coding madly. That was during the lockdown in Spain that took, I don't know, 60 days maybe, like around 2-3 months. So I was like coding all nights around this. So the first idea was, okay, that's the steps that I need to do. So I need to get this CSS, parse it and transform it into an AST, and then I need to transform this CSS into the bindings that I referred before, and then generate all the boilerplate. How more or less this works is like I get the CSS, and then I write my own parser, because in OCaml there was not a very new CSS parser at the time. There were like a few older ones that support CSS2. I needed, of course, like the CSS3 or the latest version. So I use Menhir. Menhir is a LR parser generator, which means that if you give your formal verification of your language, it's going to generate a parser for you. And it's one of the most advanced parser generators that exist, basically, right? So if the formal grammar is something like that, which this is not really like something that you would understand. This is the formal verification of a part of OCaml, but the idea is that there's some sort of notation that generates a parser for you, right? So I needed to write my own parser, basically, right? Creating a parser, it's something that I have not thought before starting this project. And while I was discovering all these libraries, all these methods, I stopped for a minute and I created like some more like toys and then like these little concepts, what LR means, what context-free grammar means, and all these like things that I heard them in my career, but I never took attention to them. So that was like the time to invest in learning. The only idea that needs to matter today is that you can have like all your CSS definitions are based on declarations. These declarations have property and value, right? And this, of course, needs to be translated to AST. This is the happy path, like 3 properties or a list of properties is the easy path, but we can work with the stuff on your right, and we cannot work with stuff on the left. On the right, we can understand what are those declarations, and after that, we can turn this AST into the bindings, right? So I can translate easily properties and at compile time, right? The last step is like, given these styles, I need to generate like all the boilerplate for a React component, right? Sorry. Yeah, so I got my project. I was super happy. You would write CSS. You would have type safe. It was like I was on top of the wall. So I went to Twitter. I tweeted out. I was super happy. Got a lot of traction, a lot of feedback. But there were a few problems, of course. Problem number one is that interpolation was not implemented, which means like the interpolation that you could have in JavaScript means that you could pass props to the component, and these props can go to the values, right? That was like, okay, that's something that we need to figure out. There was another problem that people came up to my repo say, oh, this property it's not supported. And I was like, okay, I need to create a pull request to another repo, update my repo, publish a new version, just for one little variable. That was very annoying. So in order to solve this problem, it was just add type safety to the CSS parser. That's easier, right? No, that's not that easy. So the question was like, how can we do that is that even possible? Like, can we know which properties goes with which values? Can we, where this information comes from, where does it live, right? Like properties, I think there are like 200 properties, and these 200 properties can have any sort of combination, almost. Okay, there is some data around the internet, and the end, like the Mozilla documentation, they do have this data. So it was just a matter to grab this data and do something with it, right? So what we did is we grabbed this data and we wrote another parser for their specific language. I'm going to explain exactly what it is now. And then I just need to generate a parser combinator, right? What Eduardo would say, super easy. That's the 1 weekend. So one of the problems is that, of course, this data is huge, right? And it uses a notation or a syntax called Bacchus-Naus form, I guess. And it looks trivial to understand for the humans, but at the first grabs, you have no clue where it is. It's very similar to the grammar, formal grammar that I explained before. So one of a cheat sheet of how it looks like is that there's these small operators. So the grammar is this one, right? I cannot even see it, but the idea is that you could write with spaces means something. The pipe means what another. The double pipe means doesn't matter the order, etc. Right? So when I just saw this, or that was half implemented between me and Eduardo, but when we saw this, it was like that's perfect for a parser combinator because we just need to implement these combinators, and then we can support the entire CSS, right? Okay, like the concept again, super easy in my head, very hard to implement. But the idea is that, for example, a property like border, and you can have none, that's the value. You can have just the line width, that's border 1 pixel. You can have the line width and the line style, and you have the line width, the line style, and the color, right? That's the definition of border, or at least a bit changed, but that's kind of like the definition. As well, you would have all the references. So line width is not a primitive in CSS. Line width can be a length, which is a primitive, and then a few other variants, right? So that's kind of like the mental model that you can think of a parser combinator. And the idea is that you would need to have a function that for any input, you would need to parse all the variants that you have in the definition, right? I think my words didn't make any sense, but I think the code did that, right? So that's pseudocode, but the idea is that you would have a function that given an input, it would say, okay, that's fine, that's fine, that's fine, or this one is really not fine, and it could give you some sort of a good error message. One of the okay, I don't know. So one of the error messages that you can get is that, okay, display blocky doesn't exist. One of the few options are all of these, right? That's the errors that we have now. But yeah, it was possible because we knew all the definitions that we got. Right. Seems that I cannot pass. Okay, so at that time, once we implement all of this, I was truly happy because you can have type check CSS, which I'm not aware of anyone who did that or wanted that. So we from the first day until that moment, it was like, okay, we did something that was for like maybe nobody cares, but for me was really impressive. But we still have like the problem number one, right? Like there was like no interpolation. So following more or less the same syntax, we thought, okay, let's try to get the same concept as interpolation, but limit it a little bit more to be very friendly for our parser. The idea is that those values cannot be interpolated anywhere. They must go into values, right? So you can only pass the color, and this color needs to be the color. You cannot put it as a property, okay? The idea is that you can have the syntax, and like the ppx or the compiler needs to transform it into this one, right? As you see here, size and color are variables that are in scope, and they come from the function, right? These two variables at this moment before the compilation, they don't have any type, and that would be unsafe. But once you run the compiler, OCaml is going to say, okay, because font size expects a CSS length, size needs to be length. So by type inference, we have an API that turns to be type safe, right? So the color that you need to pass to heading, it needs to be a CSS color. If you pass anything else, you'd have a perfectly nice compiler error. I'm not going to say, I expect a color, you give me something else. Fix it, I don't want to run. At this time, another celebration, that was like a moment where this was like a proud moment I have, where I got like these type holes, so variables that you have at runtime to be type safe. It was one of the first problems that I suffered, I don't know, like 2 years before. So that was kind of like a big moment for me. The kind of like wrapping up the whole project and the whole presentation, one of the first conclusions on learning to go is that go with a mission approach. When I started, I wanted to go very minimal to not make anyone rewrite their thing, or was scared to break up with the community, or whatever fear they got. And once I said that's just bullshit, I should go with ambitious and try to port the same ideas to another language and go deeper as I can until kind of solve it. That worked for me, but I can recommend for anything else. The other one is that your open source project can become your job. At some point during this journey, Ahrefs contacted me after the Twitter thread and all of this, and they offered me a job to work full-time on this. So I know that GambiConf is a little bit to your pet project and your fun project, but at the end of the day, if you keep pushing, and there's real value, there's going to be a company that's going to pay your time. So for me, that was really great, and I hope that if you have the energy and the time, it works for you as well. The other one learning is that writing a ppx is a great path to write a compiler. Writing a compiler has all these massive specs or a lot of fear because it sounds super complex. I can say confidently that 3-4 years ago it felt the same for me, but now I'm overconfident on writing a compiler because I have been doing it for, I don't know, 2 or 3 years, and the concepts are the same as you are doing in your day-to-day job. It's just the mental models are different, and of course, a lot of people have put a lot of thought into it, but it's just a matter to translate this knowledge into your own knowledge. And once you understand what a compiler is, you can talk with same concepts as people who wrote the language they speak, which I think is kind of the next level when you're working or you are very interested in programming languages. So that's a path that I would do again. And the kind of the last one is that OCaml and Reason are fantastic. I wouldn't be here or I wouldn't be in my job if it wasn't for these 2 languages. So yeah, if you have time this weekend or next week, you can try them out. They are fun. And that's kind of my last slide. Thanks for listening to me. And if you have any questions, I'm happy to answer any. Perfect.
Okay. Thank you very much, David.
Thank you.
Let me grab this the mic from you. Oops. I didn't know that was Thanks. Thank you. Well, right now, we're going to have some time for the lightning talks. The lightning talks are a place where you can share your ideas, your side projects that you're building in your day-to-day life. And if you have any desire to talk right now, you can raise your hand and you can come here and talk about your project. Does anybody here is building a side project that wants to talk about? Somebody? Oh, you. What's your name?
Macabeus.
Go ahead, Bruno.
Okay, yes. So I want to be able to use my computer here. Just a minute. After that, you have the Kahoot with the speaker talks, etc. And you have a lot of t-shirts that you can pick one from this side. Okay. Ok. Ah, não vou precisar disso aqui, não. Só pegar o VDL Ninja. Consegue ver? Não sei se estou no VDL certo. Tô? Ok. Deu certo? Yes, I have a lot of tabs open on my browser. Okay, so Okay, one of the motivations that I decided to organize GambiConf, etc., is because I like to share a lot, I like to make a lot of personal projects, etc. Here is my GitHub, okay, Macabeus, Macabeus. And for a long time, I like to do some personal projects, to try new ideas, to share my, share what I'm doing, etc. And so one of my first big personal projects is this one, about a compiler. Someone here played the Ragnarok Online. It was a very popular game. Oh, Leonel played the Ragnarok, etc. Yes, my sister. And yes, I really love Ragnarok. It was a very popular game on its time, Ragnarok Online. And on this game, but sometimes it's a little boring to play this game because there's a lot of grinding and you need to do the same action many times, etc. One of the solutions make a computer play for you. And so I decided to make this personal project that is able to create more configurations on this. When you try to make the computer play for you, you need to do some actions that need to be many times. And this personal project is to extend these possibilities to make the computer do more actions on the game. And the other personal project that I was developing is about the Game Boy Advance, okay? And there is one game in Game Boy that I really love. That's this game, Clonoa Empire of Dreams. It's a very nostalgic game, but I would like to play more levels on this game, and I want to make my own levels on this game. So I decided to create a personal project to be able to edit this game and customize, generate a custom ROM with your own levels. And it's the second project that I made. And I gave some talks about that on some conference. I have a lot of blog posts, explain the process to customize the game. And etc. I just want to share that. Ok, thank you. Podemos fazer o Kahoot aqui no computador agora.
Okay. Oops. Okay, let me just share this. Oops. Oops. Just a little while, because I set up this on my cell phone, and it's a little bit tricky to, I'm gonna contact the iOS developer that made this, because it's a little bit buggy. You can open an issue on GitHub. Let me just reopen this. Sorry about that. Oops. It's not showing up. Oops. Oh, nice. Okay. Tá carregando aqui. Eu tive que logar pelo computador, porque pelo celular ele não consegue fazer o...
O share screen?
É.
Ah, tudo bem. Mas consegue abrir aqui?
Tô tentando. Estou logado já? Tô logado.
Sim, vai dar o play agora?
Uhum.
Iniciar. Mas as pessoas vão conseguir ver... Você vai conseguir controlar do seu celular?
Do computador.
Consegue controlar daqui? Tá com
Consigo.
share screen ou tá do computador?
Tá com share screen do master, que é o computador.
Mas as pessoas vão conseguir ver as respostas daqui?
Não.
Não? Ah, tudo bem então, beleza.
So yeah, you can scan the QR code or just go into kahoot.it and paste the pin of the game. Right? Oh yeah, just so you know, the person that wins the Kahoot is gonna win the last T-shirt of GambiConf. Everyone's in? CR. Is someone missing? Can I start? Can I start? Okay, I'll start now. Which hex code denotes the start of the JPEG image? The first one is the blue. Is the yellow. Is the green one. Ooh, nice. Okay, 8 people got that one right. Let's go to the next question. Of course, Blagoy, of course. Which of these libraries is used for text recognition? It's Blazor, Sarzak, Tesseract, Vit. Three, two, one. Okay, most of you got it right. Nice. It's Tesseract. Next question. Of course, Blagoy again. Of course you know. Wiki right above. How are the parts which describe a specific segment of video file format structure called? It's markers, atoms, pointers, or references? 12 answers, 13 answers, 15 answers, 5, 4, 3, 2, 1. It's atoms. Wow, most of you got it right. Only 3 people missed for markers. Nice job, guys. We're going to streak. And Bruna is coming hot. Okay, next question. What's the name of the JavaScript feature that isn't available in Reason or OCaml? String with backtick, template literals, literal strings, quoted ppx. Which one is it? 3, 2, 1. It's template literals. Wow, you guys are paying attention. Most of the answers are right. Nice. Blagoy, still leading. Luis, right below it. Next question. What's the name of the library used to write the parser? Smelir, in here. Rstat, again here. Seven, 6, 5, 4, 3, 2, 1. It's men here. Nice. 8 answers right. Blagoy is still leading with Luis right on his tail and Bruna as well. Let's get to the next question. After the rebranding of Reason, what's the name of the language? It's ReasonML, it's BuckleScript, it's ReScript, or OCaml.js. What is it? 3, 2, 1. Wow, you guys are paying attention. Nice to see. It's ReScript. Oh, my guy missed the first place for Luis. Nice. Next question, what does mutation testing check? That our code is correct and our designs are pretty, that our code is fast and maintainable, that our code is meaningful and our tests are strict, that our bosses will recognize our efforts and give us a big raise. What is it? Well, nice. You guys are paying attention. Yeah, that's right. Is that our code is meaningful and our tests are strict. Luis still leading with haze just below it. Nice. When was mutation testing first proposed? 1971, 1951, 2011, or 1991? When was it? 12 answers, 5 seconds, 3, 2, 1. 1971. You guys are really nice. Only a few of you got it wrong, and Luis on a streak. What does it mean to kill a mutant? It runs out of CPU cycles. It makes a test fail. It runs out of Ethereum gas. Gas is expensive. It makes the machine crash. What is it? 3, 2, 1. Wow. Wow, guys really paid attention. Okay. Only one of you missed. Luis, on fire. And the last question. What was Stan's first gaming console? A Game Boy, a Mega Drive, a PlayStation 2, or an Xbox? I hope Stan got this right. Three, 2, 1. Wow, a PlayStation 2. That's right. Well, let's see who won it. In third place, Dave. In second place, Hayes. And in first place, Luis. You can come up here, Luis. Bruno. Bruno. Come here. Really nice. Congratulations.
Thank you, Macabre.
King of Kahoot.
Yeah.
Nice one, Luis. That's nice. Thank you, guys. Thank you. 50% of correct answers. Nice? That's nice. Well, we are reaching the end. Thank you, everyone that played this game. Congratulations, Luis. And now Bruno is going to say, oh, what? What happened? Oh, yeah, there's still food. You can eat it. Let's not waste the food. Food is not meant to be wasted. We can go there and eat. Bruno, do you want to have your final words in this? Let me just grab the mic.
Okay. No, just to say thank you for everyone. It's a pleasure to have everyone here on the holiday. And thank you for coming here. Thank
you very much, guys. Well, let's eat.
Estou realmente cansado com sono.
Já.
Eu estou nem conseguindo mais falar direito.